Yo-yo, topic 5, lesson 2, solving one-step equations. Notes. If you recall from lesson 1, we were talking about an equation is a math sentence where the left side and the right side of a math sentence are both equal. And in lesson 1, the variable was already by itself. And today we're going to notice that the variable is not going to be by itself today. So we have to do some things mathematically in order to get that variable by itself. So to solve equations where the variable is not isolated, we must use inverse operations. Inverse is a fancy term for opposite. So the inverse of addition is going to be subtraction, right? Those are opposites. We should all understand that. The inverse of subtraction is going to be addition. The inverse of multiplication is going to be division. And the inverse of division is, of course, going to be multiplication. We come down here, I'm just going to name the inverse of each of the following, right? So the inverse of multiplying by 4 would be to divide by 4, right? That would be the inverse or the opposite of multiplying by 4. What would be the inverse or the opposite of adding 17? It would be to subtract 17. The inverse of dividing by 9, well, the inverse, the opposite of dividing is to multiply. So it would just be to multiply by 9. The inverse of subtracting 12, of course, the inverse of subtracting is addition. So we would add 12. And that would be the inverse of that. The inverse of multiplying by -3. Now don't get confused here. I'm just going to change the sign. The inverse of multiplying is dividing, and I'm still going to be dividing by -3. The inverse of adding -1 would be to subtract -1. So all these rules from topic 1, your integers rules, are going to come back into play here. The inverse or the opposite of dividing by -6 would be to multiply by -6. And the inverse or the opposite of subtracting -9 would be to add -9. If we come down and we start looking at some examples of one-step equations, notice that I've color coordinated them. So we'll look at the red one here. That is example 1. The equation is y plus 3. And the first thing we need to notice is that the variable is not by itself on the left side of the equal sign. So when it's not by itself, I know I'm going to have to do the inverse or the opposite of what I see that is happening to the variable. Well, what is happening to that y? I can see that it is y plus 3. It is adding 3. So how do I undo that? How do I get rid of plus 3? I am going to subtract 3. And in order to keep your equations balanced, you must subtract 3 on both sides of the equal sign. So I'm going to put a -3 there on the left side of the equal sign. I'm going to come over here to the right side of the equal sign. I'm going to put a -3 underneath the 10. And essentially what happens is +3 and -3, they equal 0, which leaves me with my y by itself, which is what we want. And then on the other side, I just have a simple math problem, which is 10 minus 3. And of course, 10 minus 3 is 7. So y equals 7. That is the only value for y that we can put into that equation that is going to make the statement true. If I put y equals 6, 6 plus 3 is 9, 9 does not equal 10. That is a false statement. So equations have got to be true statements. If we look at the yellow example here, similar to the red example, right? I'm going to find my variable. Is that variable m by itself? And of course, the answer to that is no. It is m minus 7 on the left side there. So I can see that we are subtracting 7. And in order for me to undo subtracting 7, I have to do the inverse of subtracting 7. The inverse of minus 7 would be to add 7. What I'm going to need to do to solve this equation. So I'm going to add 7 to both sides to keep things balanced. On the left side, plus 7 on the right side. And similar to the red example, minus 7 plus 7, those cancel each other out, leaving you with just m by itself. And on the right side of the equal sign, I have a 4 plus 7. And of course, 4 plus 7 we know is 11. So m has to have a value of 11. Let's go ahead and look at these last two examples in the green and the blue. Example 3 is 3g equals negative 15. Remember, when the variable and the number are next to each other like that, that means to multiply. So really this equation means 3 times something has to give me negative 15. Again, I notice that the variable is not by itself. It has the 3 and the g are together. So I have to think about what is happening there, right? So I understand that that is multiplying by 3. I see multiplying by 3. What is the inverse or the opposite of multiplying by 3? That means I'm going to need to divide by 3 in order to solve this equation correctly. So I'm going to divide by 3 on the left side. Lots of times we just draw a fraction bar and we put the 3 underneath it. That means to divide by 3. And on the right side, we're going to draw the fraction bar and put the 3 underneath it. Now what happens here is we basically have 3 G's, 3 goats, being split into 3 equal groups. And of course, 3 goats split into 3 groups would leave you with 1 goat. So I'm going to cross off the 3's. They cancel essentially. And that leaves me my G by itself, which is what we want. And now I have a little math problem on the other side, which is negative 15 divided by 3. And we have to recall all of our rules from topic 1. A negative divided by a positive is going to give me a negative answer. And I know that 15 divided by 3 is 5. So negative 15 divided by 3 has a value of negative 5. If we come over to the blue example, example number 4, again, the first thing I notice is that it is s over 6. That variable of s is not by itself. S over 6 meaning s divided by 6. So my variable is being divided by 6. And of course, in order for me to solve this equation, I'm going to have to do the inverse or the opposite of dividing by 6, which is to multiply by 6. I'm going to need to do that on both sides. I'm going to rewrite this down underneath so we can show it a little bit better. So I have s over 6 equals negative 10. So I'm going to multiply by 6 on both sides. Similar to example 3, 6 and 6 are going to cancel, which is going to leave me with my s. That is an s, not a 5. And then I'm going to have a basic math problem of negative 10 times 6. Following my rules from topic 1, I know a negative times a positive is going to give me a negative answer. So that means my final answer is going to be negative 60. That is the only value that s can be. Negative 60 divided by 6 would give me negative 10. Go ahead and scroll down. Try these 4 examples in the colors, and then there are some extra examples here with some decimals and fractions. Please don't be spooked by these. It's the same concept. If I see adding, I'm going to subtract. I'm going to use those inverse operations, but we're just applying that with fractions and decimals. You can go ahead and pause this video, work out those 7 problems, and then check back to see how you did. All right, here are your answers for the you try on your own problems. Make sure you are understanding what is happening in the equation. Make sure you understand why I am doing what I am doing in order to solve the equation. Remember, equations, we are going to do the inverse or the opposite of what we see happening to the variable in order to solve for the variable. Check your work. Make sure it's correct. If you have any questions, make sure you raise your hand and you are asking questions. This is very, very important, especially when you get into 9th grade math at high school. Like the whole class is algebra. So we have to be able to solve basic equations in order to be successful.